Okay, good afternoon, everyone. My name is Tomáš Kypta. I came here from Prague, Czech Republic, from Avast. I will gonna speak about the various testing frameworks for Android platform. Maybe I should have mentioned that in the title. So, why do we need to test? Well, at Avast we do lots of Android applications. We have our mobile security, cleaner applications, secure line VPN application, password manager, and now we also acquired AVG, our main competitor, so we have even more applications and we need to test them and make sure we don't do unnecessary bugs. If you have been developing for Android and for some years and try to unit test your applications, well, your experience might have looked like this. It was painful experience. It was difficult to write proper tests for Android. But now it really were difficult. Currently, there's lots of new things, new frameworks, new libraries, which will ease your work, and you can, well, do almost whatever you want. But first, I need a little bit to classify what the libraries, what the frameworks are like. So there are two main types of unit tests for Android. There are instrumentation tests. These tests run on the device or an emulator, and there are local unit tests. These local unit tests run on your machine and are quicker. So first, if you open an existing project, how do you figure out where do you have to look for the instrumentation test, where do you have to look for the unit tests? Well, everybody probably knows that the main source set, there's the source code. Then the instrumentation test you will find in Android test source set, and local unit tests are located in test source set. This is the current setup. It can be changed. Some time ago, Android Studio had problems to working with both of these test source sets, but currently it works. There's full support in Gradle and Android Studio, and it works. Before I dive into the frameworks, there's one common library or framework, we can say, that everything is based upon, or almost everything, and that's JUnit. If you have tested any code for Android or Java, you probably know it. It's everywhere, and it's really the essential part for both. But be careful when you test your Android code. Pure JUnit can be used only for pure Java code. If you touch Android APIs, you will encounter a lot of problems, and I will get to the specifics later. So, instrumentation tests. Instrumentation tests, as I said, run on a physical device. You have to connect your device. You have to start your emulator, either the emulator from Android SDK or a Genymotion emulator. You can run it from Gradle. Just run connected Android test, and well, everything will run. The test will run, and then there will be a report, some HTML report in the build subfolder. How does it work? Well, you have your application code, application package, and then there's instrumentation test runner, which is hooked to your application, and there's some test code which contains your tests and mocks of your classes, and this code is hooked to your application through the instrumentation test runner, and it's applied to your application. Now, how does the instrumentation tests look like? If you have been around Android for some time, you probably encountered, well, so-called legacy instrumentation tests. If you Google unit testing for Android, this is probably the thing you will find. I write legacy because currently it's legacy, it's obsolete, and now there is something new, and there is a so-called testing support library, which was developed by Google. It's part of the SDK, and it makes things easier, much more easier for you. So the legacy instrumentation test, well, it used JUnit 3, which has different API than JUnit 4. It doesn't use annotations, and you have to extend your test from test case. In Android case, that means Android test case, or activity instrumentation test case 2, whatever that means, and service test case, and all these classes. And it's tedious to write these tests. And in API 24, Google decided, okay, let's deprecate it, so don't use these anymore. But as I said, if you Google unit testing, half of the things that you will find is this in legacy code. So testing support library. This is some initiative like 2 years old, something like that. And yeah, it's JUnit 4 compatible, so nice annotation-based unit testing. The key part is Android JUnit runner, which is part of the support testing library. To use it, you have to specify it, but thankfully, Android Studio is clever, and when you start new project, this thing is already set up. So unless you delete it, you are fine. So there's also some necessary dependency, but also it's predefined, so you are okay when you start new project. There are also other things. There are, for example, JUnit rules. JUnit rules are, well, JUnit, not well-known technology how to adjust your test. JUnit rules enables you to do some code around your test. So imagine you, for example, run your test and you want your log output in some file, or you want to take screenshots during your test. That's JUnit test rules for. So testing support library adds some nice test rules for you to use. So there's Android test rule, service test rule, disable on a debug test rule, and this means that when you are debugging the test, this test rule is disabled and it's not applied during debugging. It's very useful, for example, for various timeout rules. So in timeouts during debuggings are generally a problem. There are many other rules, like as I mentioned, logcat rule. What it does is that it clears logcat and logs all the things that will appear during your test into some file. There are other rules for example, obtaining some battery status, network status, and other things, very useful things. Again, dependency is necessary. Now, other cool thing you probably heard about, that's Espresso. And Espresso is a UI testing framework. It's also part of the support testing library. And you can write your UI test with it. How does code with Espresso look like? Well, it looks something like this. This is very simple test. You just you get your view with some ID. You, for example, type a text, close the keyboard, and then you will find some other view with some specific text. You will click on it, and then you check that, okay, somewhere else there's some result, there's something expected. So this is for testing your UI. Very useful. There might be some problems with it. What are the problems? Well, the testing is not isolated because it runs on your device, and on your device there are probably lots of other applications that, well, can do their own things. The device state might affect the results. That means, for example, it depends if your screen is on or off. This can change the result. So you can, for example, check if your screen is displayed. If you forget, for example, to turn on your screen, you will get some exception, and you will, for a while, think, okay, what's wrong? What am I doing wrong? Then Google usually helps. So this is Espresso. Espresso is more suited for a developer, and all the things here I mentioned are more for a developer, but there might be other frameworks that are more useful for QA engineers. So imagine that, okay, developers, they unit test their code, they do maybe some integration tests, but then QA engineers come and they check the application from the outside, and if it works good, if it works well with the system and everything. And Espresso is somewhere at the boundary. It can be used by both parties. But UI Automator is more for a QA. Developers usually don't use it much. For example, our QA engineers are writing UI tests and some end-to-end tests in UI Automator. So UI Automator contains some APIs for writing UI tests, and it is able to integrate not only with your application, but it can work also with the system application and other applications. So that's why it's very useful. So you can, for example, check that, okay, if you navigate to settings, you change some settings, and you get back to your application, something is different or something happened. You can do it with it. There are some limitation that it works on Android 4.3 and newer. And yeah, again, some extra dependencies, but UI Automator is also part of the support testing library. So it's all these things I mentioned are in the Android SDK. UI Automator has several parts. There's some API for obtaining views and data from your application and for interacting with your application. There's some API for cross-application work, and also there is UI Automator Viewer tool. That's a separate tool in the SDK. You can run it, and you can inspect other applications too. So you can, for example, it's especially useful, this tool, if you are writing something for accessibility. Imagine that you want, some talkback feature or something like that. You can check if what's name of these views, what are their IDs, and if you integrate, for example, with system, you can check what's in the system application, what are the names of the views, and so on. So how does a test look like? The unit test is run with Android JUnit 4. That's the runner defined in the support testing library. Then I need some setup at the beginning. I define my device, and before I start, I press home to clear the screen, and then I will create some intent and start my activity. And I necessarily need to wait some time, like 5-second timeout, before my application is started. This is some sanity check. And then I can happily do the testing. And in the test, I can find some object that has specific text, and I can click on buttons, and then I can also find objects by ID, and test that some text is there or something is there. So in this way, it's very similar to Espresso capabilities. The API is different, but UI Automator can touch other apps, not just your app. There is another thing, very useful thing. If you have been using Genymotion emulator, it has Java API. I guess it's limited maybe to some business or Indeed license. I'm not sure because Genymotion is paid. But Genymotion API can be used with UI Automator. But UI Automator has one weakness. Or generally testing on your device has one big weakness, and that's the state of the device. You, for example, want to test your application in some specific setup. For example, you have no network, or you are on a very slow network, or I don't know, you are calling somebody, you are receiving call, and you want to make sure your app behaves correctly. And on a standard device, it's difficult to achieve it, especially if you are doing it on a real-life device. But if you use Genymotion emulator and the API, you can manipulate the values of the sensors, and it can help you and ease your pain with the code. You don't have to write some special mocks for the sensors APIs. There's also dependency, and it's necessary to add some extra repository for this one. And how does it look like? So in a test, you can, with Genymotion Manager, you can check that, okay, I'm running on Genymotion. Now I can proceed. I get my Genymotion Manager, and I can, for example, get the radio and start calling somebody. Or some other things, I can set some network type and make sure that my app works well even on slow networks and when the connection is really terrible. So next thing is Appium. Appium is a framework that's not limited to Java. And also it's not limited to Android. It's for iOS, Android, Windows. And it's based on a WebDriver protocol, whatever it is, just Google it, it's better. So it can be seen as an alternative to UI Automator. So if you, for example, have QA engineers who don't handle Java and don't know Java well, it's better to maybe use Appium, because in Appium you can write the tests in basically any language, in Python, PHP, Ruby, whatever. And it aims really to test it from any language, and it's still able to access, for example, the web-based APIs and databases and other things. There are some limitation for Android 4.1 and newer. Now, instrumentation tests are generally considered slow. And that's why Android developers were, for a long time, they wanted to use unit tests on Android. And this was the very painful part for Android to provide. Instrumentation tests, they were historically supported. Unit tests, it was historically a big problem. Because unit tests run on JVM, and on JVM, on your development machine, you don't have the Android APIs. You don't have the code that's on the device, the SDK. So to enable testing it, the SDK now has so-called mockable Android jar. It's Android jar with some empty implementations of the APIs. It does nothing, but the mockable, it's because the final keyword was removed from all the source code. To test unit tests from Gradle, just run Gradle or Gradle wrapper and test task. And it will run the test and generate some HTML report again in the build folder. For unit testing, there are lots of frameworks. So there's the JUnit, there's the Mockito that's well known and probably the most used. There's PowerMock, another mocking framework, EasyMock, again, another mocking framework. There's Robolectric, there's Cucumber, there's, for example, Hamcrest. Hamcrest is just a library containing some matchers so that you can check very complicated conditions easily. Hamcrest is not limited to Android in any way. That's a general Java framework. So JUnit. I mentioned JUnit, and when you run it on pure Android code and you don't have any mocks, then you will get this exception, method not mocked. Okay, so what does it mean? Well, you start Googling, and after a while, you find some settings. So you can set return default value true. So you try it, and you realize it doesn't really help that much, because this just return the default values of functions. So if the function returns integer, it will return 0. If it returns Boolean, it will return false, and again, other things. So, well, some tests might be fine, but other tests will fail. But it will not crash. There will be no exception. So, you need to mock your code. And the best way to do it is to use Mockito. Mockito is mocking framework. It's very popular. It's, we can say, it's also recommended by Google, used a lot. Very easy to use, and it's completely compatible with Android unit testing. What's more, it's also compatible with instrumentation testing. You can use Mockito in your instrumentation test too, but you need to use DexMaker. That's because Mockito generates some classes, and for instrumentation tests, you need Dex. You can't use Java bytecode. So you need some extra effort. So how to use Mockito? Well, first you have some test class, and you can have some field that you annotate with mock, and you expect some mocks. And then you will call init mocks, and it will do all the things that's necessary. And in the test, you can use it. Other thing is that you can use directly Mockito JUnit runner, and you are fine. And you don't have to call any init. Or if you need it in place, some special mock in one place, you can just use mock method and it will create mock of context. And how to use it? You just write that, okay, when somebody calls this method on context, and that means any code in your test, then you want it to return some specific value. So this way you mock your code, and then there are the results that you expect, and you can happily test. There's also Mockito Spy. Mockito Spy is a bit different. That's for wrapping real object. Mockito Mock will just create a mock instance completely new, and this one will enable mocking on existing instance. There's also Mockito Verify. Mockito Verify is a special assertion that checks some special conditions like, okay, was my method called, for example, once or twice? Was it called at all? And normally with JUnit and assert, it's basically impossible or very complicated to do this. But with Mockito, these tests are very easy. So you can, for example, test some of your manager something, and you want to make sure that somewhere inside some system API was called because it's supposed to do it, and this way you can make sure it happened. There are some limitations, of course. It can't handle final classes, although there's some incubating support that you have to enable explicitly. And I haven't tried it myself, but it's supposed to finally be able to mock final classes. It can't handle anonymous classes, primitive types, and static methods. For static methods, there is PowerMock. PowerMock is a mocking framework that's compatible with Mockito, and it's able to mock even static classes. So there is PowerMock runner, and you need to prepare classes for tests. So you tell that some static class will need to be mocked in their static methods has to be mocked. So you use, or directly you can say in code, you can say mock static, and the same way as Mockito do it, you will call just when some static methods was called, then I will return some value. The same way as Mockito is doing it. So that's for mocking, and now Robolectric. Maybe you've heard about this. It's very popular, and what this thing is? It's for functional testing of your application. It runs on your JVM, and it basically enables you. It offers you all the APIs that Android has. It's some ultimate mock of the whole Android APIs. But there's the drawbacks that it can be very difficult to get into and to understand it and get outside of the basic examples. As I said, it provides some system mock, or I can say shadow here in the Robolectric calls it shadows. So it creates some mocks of the system managers. But if there's something new and not supported, you can always create it yourself. As I said, one thing it's difficult to use because Robolectric was developed for many years, has been developed for many years, and the APIs has changed a lot. So if you Google Robolectric how to do something, you will probably Google something that's outdated and the APIs has changed, and it can be difficult to write it correctly for the latest version. It's possible to test even UI. The test run on your device, on your computer, not on your device. That's different to Espresso and UI Automator. And I guess personally, it's better to use only for business logic. For UI, it's better to use the instrumentation tests and those things. So you will run it again with Robolectric Test Runner. And Robolectric has many classes that offer the features like Robolectric Runtime Environment. That's the runtime through which you can access the context and these things. There are shadows, shadow application, for example, shadow looper. Robolectric can work with threading to some extent. So it can, for example, you can wait for some background threads and then like process them and handle even some background things. As I said, it's ultimate mock. And what are the problems? As I said, difficult to search for solutions. The APIs has changed many times and many obsolete posts. Quickly, I will mention Cucumber. Cucumber is BDD testing framework. You write tests in your human-like language, and you describe the desired behavior. So it's mainly from the point of view of a product manager. So you can say just scenario, few coffees, like I have one coffee, I add one coffee, and then, well, you expect that I had 4 coffees. So you create mapping. There is given annotation, so that's mapped to the given statement. The precondition that I have some number of coffees, you can use arguments. I add 1 coffee, and then you check the result that I had some specific number of coffees. This is the assertion here. So this is the precondition, the change, and some expected result. You run it simply. You just create empty test class, you annotate run with Cucumber, and it runs. It's necessary to have the mapping and the feature definition, the test definition in the same subfolder. Otherwise, it will not work. And last thing, from code coverage. Code coverage is for instrumentation test with Jacoco. Also, there is Emma, which is obsolete now. And for unit tests, there's also Jacoco. In instrumentation tests, the code coverage has to be explicitly enabled. You can do it just by calling test coverage enable true. You call it from Gradle with create debug coverage report, and it will create a human readable HTML file with some coverage report, and also some binary thing. Be careful, on some devices it doesn't work for some reason, so the reports will be empty and 0 coverage, and it really depends on the device. I encountered that, for example, on some Huawei devices, and I don't know why it happens. And Jacoco on unit tests, just run Gradle test, it's on by default, but be careful, it generates binary report, and you have to convert the binary report yourself. You have to write extra task. And there's also some support in Android Studio, just show coverage data, and Android Studio can show you on your source code that you have some coverage here or there, and it's really nice. So good test, run in any order, and run in isolation. And well, that's the isolation part is problem for instrumentation. Run consistently also, that's a bit of problem from instrumentation tests. Run fast, again, problem from instrumentation tests. So that's why unit tests were created, for developers to run quickly and to test quickly and consistently. And yeah, tests should be orthogonal. Don't write one thing many times. So that's it, almost. Yeah, always prefer pure Java. I guess I will skip this. And this was covered in the previous things. One last thing, we are hiring Android and iOS developers and mobile QA engineers. So if you are interested and would like to relocate to Prague, just let me know and contact me later. So, do you have questions?
Do you support relocation?
Yes, we support relocation. Yeah.